I'm happy to be here again. It's a unique situation for me because we had a workshop yesterday and I know lots of faces and I still recall lots of faces from yesterday and even you sit at the same positions. It's great. So just as a quick, to warm up my heart for the crowd, who was at the workshop yesterday? Please raise your hand. Having that much crowd control makes me happy. Thank you. Okay, so obviously this talk is again on mutation testing. I found a cool title, but the steroids part is just because it sounds cool. I needed a new title after 4 years of doing these kinds of talks. I'm talking about mutation testing. It's a super old technique, and it's a strong form of coverage. It's so old that the oldest references I could find go back to the 1970s. I forgot the names of all the original discoverers of these techniques. I second them. It's a great idea. Okay, so what is mutation testing in a nutshell? You all have been to Martin's talk before. He talked about checks. He talked about automatable checks. And mutation testing is what I call a derived check. It takes artifacts you have in your system right now, which is basically code and automated tests, and turns them into a derived check. This derived check is it's by itself automatable, and it, instead of spilling out clear violations, it spills out semantics or representation of semantics which are not covered. And there's nothing you can do about it. This tool is just super dumb. It applies a set of transformations, and with some black magic, it just shows you, here are unspecified semantics. And an unspecified semantic may look like this. This is a unified div, and I just made this up. I could have posted a full report, but I wanted to have it as small as possible. So this is our typical Ruby method. We do things, and the tool will report, will do such a report. Everybody should be able to read it. Everybody who ever worked with Git and anybody who ever saw a diff should be able to identify we are removing a method call. And this removal in this case represents unspecified semantic if the tool reports it. Unspecified semantics cannot be evaluated further by this technique. The human now has to decide what should we do with these kinds of unspecified semantics. On a mature code base, it almost always means that the unspecified semantic needs to be removed. On a not mature code base, and yesterday's workshop everything was on non-mature code bases, you typically have to add another automated check to prove to the tool, yes, we actually need this kind of semantics which you reported as unspecified, so you have to prove to the tool by adding a test, hey, I really want the semantics and I do not want it to be gone, and I want to nail for my future self or my future coworker or the future intern. This was important. This is this is a call to the VAT calculation, or it's a call to initialize your discount logic or whatever. But this tool spills out not all, obviously I cannot claim this, spills out unspecified semantics, and it's quite good at it. Okay, so because naming is fun and because I'm the author of the tool, I was in the fortunate position to make up lots of names, and we need to go through these names to be able to explain further concepts. If you later get a hand on this slide, everything which is blue links to the Mutant documentation. You should be able to click on it and then get a much more verbose version of than I can present in this talk under time constraints. There is a subject. A subject is anything which has tests and can be mutated. Currently Ruby, or my tool Mutant, only supports instance methods and class methods. There are other possibilities in the future. I could expand it into class-level DSL. I could expand it into constants. I could expand it into inheritance declarations for classes. But for now, a subject is just an instant method and class method, and I would hope that everybody has a bulk of the logics there. Then we have the match expression. The match expression is a Mutant-specific concept which just tells the engine where to look for your subjects. So imagine you were pointing the mutation testing engine against your project. You have 100 dependencies. You have 100,000 lines of code. But unless you specify to the tool which are the subjects of your interest, you're out of luck. So I made up the concept of match expressions. The first match expression is a recursive enumeration. You just give it your parent namespace, and it will recurse into all subjects it can automatically identify. The second match expression just scopes the engine to discover or to work on subjects within some class, instance methods and singleton methods. The search match expression specifies to only work with a specific instance method, and this fourth one goes with a specific singleton method. Okay, the next thing I made up is the term selection. Selection is a process to find corresponding tests to your subject. Selection is very important. Selection defines on how fast your mutation testing will work, because if you were to run the discovery of unspecified semantics against all your tests, and everybody knows how slow tests can be, you will be out of luck to have any productivity with the tool. So we need a method of selecting tests, automatically executable tests, and these selected tests form a subset of the test, and they use metadata. For RSpec, everybody uses describe and context and all these really nifty nesting primitives, and they typically do not produce any value outside of mutation testing, where Mutant uses these kinds of metadata to form an implicit selection criteria. So when you start to use a tool like Mutant, it suddenly becomes important to be honest in your describe statements, because if you're not honest in your describe statements, you miss to give fine-grained enough metadata. The tool might select far too many or far too few tests, which in case of far too many tests results in terrible runtime, and far too few tests results in terrible coverage. So you need to stay alert and learn the concept of selection. Minitest is a little bit different, because Minitest is low on implicit metadata, because typically there are two forms of using Minitest. There's a describe syntax, which is more RSpec-esque, but I so far didn't implement any kind of metadata extraction. You have to go with explicit coverage declarations. You just declare this specific test class covers this specific expression, which Mutant then will internally use to do a good subject selection. The next thing, this is not a word I was fortunate to make up, it's in the literature. Imitation operator. Imitation operator takes a concrete subject into a different form that, if when applied to your test, doesn't get noticed by the test. And this application of a different form forms your reports, the report I showed before here. This is the report of applying a specific operator against a subject foo, which is an instant method. So this, for example, is a semantic reduction operator. We have the body of this method is formed of two method calls, and we removed one, which is an operator which reduces semantics. There is another class of operator I didn't show so far. It's an autogol replacement. You have been fighting autogol replacements yesterday a lot on the range example in the workshop, where Mutant was taking lower than to a lower than equals, or it was inverting an AND to an OR. You cannot argue which of these operators have less semantics, hence I call these orthogonal replacements. Okay, a mutation is an application of an operator against a subject, and the result of the tests ran for this subject are a mutation. If the test is green, the mutation is alive. Alive mutations are the ones you're dealing with most of the time. Alive mutations are bad because they, via an automated deriving prove that something is not specified in your code base. And I will just beat the dead horse over and over again, because it's the most important message. If an automated process can find unspecified semantics in your code base, you have two options. You remove these semantics or you specify them. And it circles back to the talk Martin has been doing before. This is an automated derived check, and each of these alive mutations should be threatened, should be not threatened, is the wrong word. It should be identified as a flag which has been done automatically on your code base by a human, and the human is asking you, why can we do this change? And we do it on a system doesn't care, or process doesn't care about this change. There is wiggle room in our code. And this has to be taken really seriously, because an alive mutation represents something which an intern, your future self, your coworker will do while you're on your wedding night, and it will rent in production, because without dealing with alive mutations, there is basically aggression about to happen. It's very likely the case that your code, as is right now, I will show you again this report. It's very likely the case that your code is correct. The problem is it's not proven to stay correct over time. Required semantics change, code gets changed, commits land. Unless you are able to specify what your required semantics are in a way they cannot be changed unnoticed, you will have regressions. And the only the only way we have in Mutant, in Ruby is a dynamic language. We have a very limited set of dimensions of enforcing correctness, and the only way I found to be valuable on the long term is really strict semantic test coverage. And Mutant is a tool which basically only exists because we were suffering from regressions, and we were like, okay, so we did this change which was bad, and nothing in our process was able to detect this change. What could we have done? What kind of automated check we could have derived from this information? And we came back to mutation testing and said, okay, so if we had a tool which would run all possible changes against our code base and ask our test if this change is in some form covered, then we could potentially avoid in the future doing bad changes without us noticing. Because if a change is accompanied by a test and the test shows we want to do VAT calculation, and I have to remove this change to make a bad change going into the code base without violating a check, then if I still merge it, I'm a moron. But okay, let's go back to nomenclature because I like it so much. Now are the preconditions. To run a mutation testing tool, our test suite or our process needs to produce the following artifacts. We need green tests. They do not have to be when you are working on a PR or a commit. Not all your tests have to pass, but the tests which are selected for your current subject you are working on with mutation testing have to pass in the first place. Else, the mutation testing engine cannot derive a signal. If the tests are initially read, the mutation testing engine's objective is to find the right test. If they're initially read, the mutation testing engine just bails out. And the first step of the range example from yesterday, I actually liked doing the workshop before. The first step of the range example from yesterday stopped the engine with a so-called no-op error. It was telling you your tests do not pass in the first place. Fix this. And we have to start with green tests. We have to have idempotent tests. Mutation testing runs your tests shitloads of times. So you will have on 10 mutation operators on a selection width of 10 tests, you end up with 100 test executions. If your tests are not idempotent because they use an I/O resource in a non-repeatable way, mutation testing will fail you. Tests need to be randomizable because mutation testing engines try to minimize the amount of tests being executed per mutation, which means that you will have an arbitrary subset. You will not always have the same sequence. The mutation testing engine will decide to run your code. If you have two tests which depend on being both ran in the same order because one test creates an artifact in your database and the second test depends on the artifact to be present, the mutation testing engine will fail you. If you want fast mutation testing is a really easy to parallelize operation. You want concurrency hard tests, which is really hard on a certain test on a certain web framework. Everybody will mention in a few seconds. And tests have to have selection metadata. If you have tests which can fail, but there is nothing attached for the mutation testing to derive a good selection from, you won't have any fun with mutation testing. And first and foremost, tests need to be discoverable, and we will have a panel about autoloads and bringing stuff into global scope later, which leads me to Rails. And all of the points here, all the preconditions are more a challenge on Rails because Rails defies all these preconditions in some form. Let's go back. Discoverable subjects. So what kind of process you can apply to a Rails code base to probably enumerate every constant which may come into scope? You have to force to expand all autoloads, but many autoloads are hidden inside some kind of code branch which only gets evaluated after a certain URL is hit and after a certain third-party library is loaded, whatever. So discoverability is hard. Green tests on Rails are more hard than they should be, but I would say this is not a big issue because most people should produce green tests. Idempotent tests. As a consultant, I see too many test suites. If you run them 2 times in a row, they fail. They can only run successfully on a very pristine CI environment or with some extra command in between which clears out DB state or remove some temp file, whatever. So it's typically an issue. Randomizable tests. Many test suites I have to work with or start with depend on an implicit sequence. Test A has to be run before test B because we are creating the payment method and it leaks into the next test and all this implicit semantics. Concurrency hardness, yes, I would argue it's not really rate specific. It's just if you're using an external I/O resource and you do not manage concurrency correctly, you will have a hard time. If your tests touch the DB, you have a shared resource. It's okay. Let's say it's still rate specific. It's still a problem. And selection metadata is not too much a big problem for Rails. Okay, so if you were to start now with mutation testing and you started yesterday, the most frequent question I got after the talk is, if I were to start now, we are in a deep problem. The tests would run. We have thousands of subjects, and I just learned from the experience in the workshops that even on a single subject, it takes 10 seconds to get a good result. So how would I start on a real commercial code base? Incremental mutation testing is the key. Your mind will rightfully refuse to deal with an alive mutation of a subject which was not written by yourself and is in the code base for 10 years ago. But why even work on these kinds of subjects? We all, as human beings, our attention level is focused on the current task. We are working on a feature, we are working on a specific class, we are working on a subset of subjects. So with incremental mutation testing, which is the key to start today, tomorrow, next week with mutation testing, you are automatically focusing the tool to only look at the subjects which had been touched in your current iteration. And Mutant in particular uses a since flag. It was not in the workshop yesterday because yesterday we were establishing foundations. We were not writing our own code. We were not creating feature branches and so on. But if you later get a hold on the slides, there is again a blue word, which means it's linked to the Mutant documentation. Incremental mutation testing is a way to start your journey today, tomorrow, whenever you want to. And here are some links to check out later. Here is a thank you slide, and you will notice that the order of the elements doesn't matter, but it does matter because we have an established rule. If the order of elements do not matter, we just sort them alphabetically to just document it doesn't matter, to remove the noise. And with that, I'm already closing this talk because this talk is only about establishing the nomenclature, seeding the idea, and then move on to the workshop which we had yesterday. So I'm a little bit, in a pickle. Okay, and I really hope for a good Q&A, which you can start any moment. And I really hope I didn't answer all questions yesterday. If there are no questions, I will ask your audience questions.
I really like this approach of mutation testing. But
where are you? I don't see you. I need eye contact. Oh, thank you.
I'm feeling that it's kind of an overhead in a lot of projects or from the client point of view. And from your experience, what do you would recommend? Is it a mutation testing for every, in your opinion, for every kind of project, every client? Or
yes.
Is it like we should start from the domain, like the core domain or core business features, and then slowly go wider?
Okay, these are 3 questions in one, and I will try to start with the first one, but I may forget the second and third, so I will have to come back to you. What is more expensive? Your coworker trying to mentally disambiguate, is a specific branch of my code covered? Is the semantic effect of a method I could remove covered? Is this more expensive in terms of use of client's money, which gets encoded into our hourly rate? Or is it more expensive to run a tool 10 seconds, which irons out 90% of all questions a human reviewer could ask already? That's what I typically ask my clients when I tell them we are using mutation testing. It takes 10 seconds, 20 seconds for a single subject to get mutation tested typically, and it runs more experiments on finding uncoverage than a human could run in this time frame. The CI integration in incremental mode is relatively cheap to achieve. So the question is a no-brainer when you have a client which understands that human time is the most precious and most expensive resource in a project. So that's typically a really nice way to alleviate these concerns, because in effect it reduces the amount of time you have to spend on asking stupid questions like, is is the equals sign here actually semantically relevant? Or shouldn't we use greater than equals, or should we use so and so on? So all these questions had been answered before, because the mutation testing engine came back to you and said, yes, I couldn't change it to something else which is close. I couldn't remove this method call. Reviews go faster and have higher quality, because it's just a lower bound of coverage, but the tool will never have a bad day, where humans will have. So clients, to my experience, clients typically actually do not care. They only care about the amount of progress per time units they pay for, and it's my duty to increase this metric. And using this technique makes me faster, because I get 90% of all dumb questions answered by a machine. So that's basically the point. And you also had some questions on the business logic and domain-driven.
Not exactly about domain-driven design, but I use the core domain. I mean the core features, or for the client perspective. Like
yes, but the thing is, any line of code can blow up in your face. So using it everywhere is just, in my opinion, warranted. It doesn't matter if the bug is in your core domain, or if the bug is in rendering a view of for rendering. Basically, you could change the code which renders the year into the copyright year in the footer. It's on every page, and if that one is not the core domain to render that one correctly, but if it blows up, it takes down the entire application. So just trying to find the perfect place to do mutation testing is, in my opinion, futile, because especially in Ruby, everything can kill everything. So I would recommend to run it every time, because it's so cheap compared to human time.
Okay, thanks.
Thank you for question. No, I don't do this. The question was, how do I integrate it with the CI? So I use a very generic very general match expression. So let me go back to the slide. So let me go back to here are the match expressions. So we use the kind of the first line match expression. So fortunately, because we're doing this for a long time, all our code is namespaced into one namespace. So we can just tell it here, find all subjects in there, and then subset it with incremental. So let's say this match expression evaluates to 1,000 subjects, 2,000 subjects, but in incremental mode, and I really hope you follow the documentation link, because I couldn't go into it, it will automatically subset this to 10, 20, 5 subjects which were touched in their current PR. And in this mode, it's fast enough to run on CI in your normal cycle. And in case you have a rates application which is a little more canonical, where everything is just a separate controller living in the top-level namespace, you can write a small wrapper which just enumerates all the discannons and create n subject expressions. So Mutant takes you could of the second line, where you can just say, these are my classes, you can just specify 10 hundreds of them on the command line. And if you write a small wrapper which just finds all of them, you can just retrofit it a little bit. But I really recommend to go with a good top-level namespace for various reasons. Good question, thank you.
Hey, unfortunately, I haven't attended the workshop, yesterday's workshop. So do you have any example of the output of the mutation?
Yes, this is basically what the mutation testing outputs, and many of them. The mutation testing engine basically output diffs. And each of these diffs represents one of these automatically found flags to your codebase, which you could apply to your codebase today, and all your specs still pass, and then you have to ask yourself why. So this is how the output looks. It's just, but many of them. I just presented one. Okay, and it doesn't only remove stuff. So it flips integers from positive to negative. It flips 1 to 0. There's a really big list, and on the operator slide there is a link. Class of changes to this link goes to all mutation operators Mutant does.
Thank you.
More questions? Yes.
Is it possible to run this tool and find out the, let's say, worst class possible that you have in your code base, that when you are so the tool output a lot of mutations for it? That
yes.
You should focus on it probably to fix tests for it.
So the tool was written in a way on how I like to use it. It was a constraint I have run it for this open source project. Everything I presented here is in the open source, but for other reasons, this open source project will not be developed by me myself anymore. But I only use this tool in incremental mode on commercial code bases. So I never, and because our turnaround time, we touch basically everything within 12 months. So I never had this, I need a list of bad things I need to deal with and some kind of a bucket list. I never had the urge to do this because I know I will touch anything, and because it has to come green on the CI, and I have to do this extraction commits, which Martin explained. I never had the need to do this, but conceptually it's definitely possible. And I would even argue that the amount of mutations generated per subject is a better complexity matrix than cyclomatic complexity. So you could run only the mutation generation engine without the killing part, and just measure which subject generates the most mutations, because this is much better measurement of complexity, in my opinion, than cyclomatic. Especially cyclomatic is hard because in Ruby you have problems statically assessing the control flow.
Thank you.
Hi. Do you have experience with mutation testing from another ecosystem?
Yes.
As well?
So
And
I've
did you just
been
port it to Ruby or
my experience started when I was joining the Datamapper 1 team, and there was a very ambitious sub-project for Datamapper 2, which is the Axiom relational algebra engine. And this was developed with Haeckel, which is some kind of a logical predecessor to Mutant. It had all sorts of problems, and this is where I was introduced. But meanwhile, I've written lots of private integrations against company or domain-specific DSLs in many languages, because the concept is very universally transferable. And there are mature mutation testing engines in lots of different ecosystems. You will find a good one for JavaScript. There is a recently new one for Scala, C#. So it's gaining traction community-wide, development community-wide, not only Ruby.
Thank you.
More questions? Yes.
So have you used Mutant to test existing popular libraries in Ruby?
Only when I had to fix, when I had to do a bug fix because of client's work. So I have a strict policy to not go broke on open source.
Okay. And why?
Yeah, because open source is when you do it, it's to me very addictive. And if I were to start other people's shit and get a little bit of praise out of it, it works like cocaine for my brain. And I need to avoid this because I need to make a living. So I need, yeah, that's basically.
Okay, so you don't have experience of...
Yeah, I have experience, but only for bug fixes I submitted to these libraries, and then I don't typically mention Mutant. I just send the code which is mutation tested, and because I don't have the time to educate other people, because that would lead to this open source spiral.
But did Mutant identify the bug, or did you identify the bug and then use
It depends. So it's very often the case that when you cannot kill a mutation, there is an underlying... So sometimes you have a mutation from one form to another form, and the mutation is equivalent. In terms of semantic observability, it's called an equivalent mutation. And when you go to the literature, all the scientists and all the computer scientists freak out on them and like, this is the biggest problem, we have to solve it. And unless we solve the equivalent mutation problem, this tool is worthless and so on. But I don't agree, because it happens so infrequently, especially when you only go with semantic reduction operators. But what happens most of the time is that your code delegates to some library, and there is a semantic weak spot in the library, and some mutation on your side cannot be killed. And then you look into, oh, this library accepts a nil here, but should actually blow up or silently swallows an input when it's malformed. And then you just upstream the fix to the library, and then your mutation comes back dead. So this is typically the case. But I've seen other people using mutation testing for open source also, and probably you can ask them.
Thanks.
So if you hit the situation that you have a mutation that you decide to not kill because you think it's equivalent or something like that?
Yes, so if I have this situation, there are basically the following things to do. I just sit back and ask myself, why does this mutation exist? This mutation exists because of a certain axiom, which is redundancy provides no value. So if I have a mutation which comes from a semantic reduction operator and I cannot kill it, I really need to ask myself why I cannot kill it, because it should obviously have less semantics than before. And if I have no proof for the extra semantics, it's very likely the case I can kill it by just changing the code to the one the mutation showed me. Because then the extra semantics are gone and the mutation testing never goes back to the original form, because that would be adding semantics and would violate the core principle of this mutation operator. So it happens super infrequently. What happens sometimes is an autogoal replacement. For example, if you have a negative number and you multiply it with a constant, and this constant turns and you then wrap this into an absolute, and this constant is positive in your code, and Mutant would just change it to the negative constant, but because it's later going into the absolute anyway, it doesn't matter if you multiply with a negative number or the positive number. To my experience, it happens so infrequently that I can at some point just do something really stupid, which is do a method expectation to make sure that the positive number is used. You can do the stupid things in Ruby where you can reach deep into some code and just say, hey, I expect that the multiply method call happened with a positive operator and then this mutation is dead. It happens so infrequently on a really big Rails code base, the one I am on with Martin. We have lots of business. We have maybe 1 or 2 of these cases. I would not get discouraged from this tool because of this reason.
But it's not possible to tell Mutant to ignore this mutation.
No, it's very deliberate, because if I ever find myself in the position to doubt what the mutation does, then I always had to cycle back and was basically just identifying I was violating a core principle because I insisted on using something complex where something simple would work. So that's the reason the operators are laid out alongside these axioms. So I don't usually have to run into this problem. Because if I run into a not killable semantic reduction mutation, I have to fight against a long legacy of axioms, and I will probably not win.
Okay, thank you.
And by the way, mutation testing, when you have a green code base after Mutant, it does not guarantee your code is correct, nor it doesn't guarantee it's good tested. It only guarantees that the automated tool couldn't find any holes. So for me, it's the first line of code review. I typically never hand code to my coworkers which is not mutation tested, because it would be a disgrace, because why would I ask a coworker to verify something a machine could do? It's just like asking a coworker to do a type check if we were in a typed language. It's stupid.
I have a question.
Sure. Yep.
So I want to ask if sometimes beside the whole regression detection feature, you can use it in some legacy code to just check which places should be refactored, because I don't know, there is so many mutations that at the first point you see that the code should be refactored. So basically the question is if you could use Mutant as a detect which code we should refactor to.
Yes. So what very often happens is that when I have to touch a class which was never touched before, that the first thing I do is I just run Mutant and look at all the reduction operators, and just my first refactoring commit is just to kill everything from the method which the tool removed for me where I had no proof, and after manual verification I couldn't verify that it's actually useful. So you can use it as you don't have to. You can use this tool to just learn about possible refactorings. So you can just run it without test integration, no kills, just show me all the mutations, which sometimes gives you an idea on valid transformations you could do. Yeah. So basically, or what's really helpful is when you have to, let's say you have this typical 20 ARM case statement you will find in some business logic when you take over a project. Before you refactor it into a nice private method with a dispatch table and all and so on, what's really helpful is sometimes I just specify this mass to pass Mutant, and then I move the public interface to specify everything through one public interface, and then I'm free to refactor the heck out of it while keeping the coverage at the same level. That's really nice strategy.
Thank you.
We successfully answered all questions, or somebody... I only see thumbs up, it's not a question. Okay, so let's conclude. Thank you.